Okay, we're gonna get started here in a second. Can you guys hear me? Yeah? Okay, all right. Josh, is that one of the green screen backgrounds behind you? Calvin in one of the other classes, I think, had Monty Python going on in the back. It was pretty funny. So. I don't think this is going to be a very long conference unless you guys have questions. It's too bad you don't get to do the lab, but the truth is I saved you a lot of work. It took me about 3 hours to do the lab. It's really hard to do by yourself, but that's all right. Do the best we can.
This dude, Kobe.
What?
Little quarantine, buddy.
Show yourself, Tay-Tay.
I don't even know how to.
Hmm?
I don't even know how to.
Nah, you're definitely too scared.
I think I did it for one class and I accidentally said no video. Now I can't.
What's that? Oh, really? I have a meeting here starting pretty soon, but I'll come over afterwards. Okay, I would like to know. Yeah. Okay. I think I'm going to go ahead and get started. Do you remember the last whiteboard we did from this first worksheet here? We were looking at two coils, and we said the magnetic field, if you're gripping these coils with your right hand, so your thumb is pointing down, your fingers will enter the left end and kind of come out the right end. So it acts like a magnet where the right end of the magnet would be the North Pole and the left end would be the South Pole. This is kind of where we left off at. So I'm kind of curious here. What do you think would happen to the magnetic field, or how could we change the magnetic field given that arrangement? Some ideas.
Increase the current?
Yep, that would be, I think that makes sense, right? If you'd have more current, you'd probably have more magnetic field. That seems like a good lab to do, that maybe we could check that out. Can you think of anything else you could change besides the current?
The radius of the loops?
Maybe change that. So in other words, make it a bigger radius loop. How about if there was more loops? Do you think that might affect it at all? Yeah, maybe. Okay. And what about the spacing of the loops? If you look at the spacing here, you know, they're about, I don't know, let's say 1 centimeter apart. What if we made it twice as far apart? What do you think that would do to the magnetic field? Or maybe closer together. Well, that's kind of what we're going to be doing in this lab. And so I think I want to kind of show you the setup behind me here. This is a Slinky. And I've got the current source over here. I've got a tap switch so that I can tap it on and get a certain current. Right now I've got 1.53 amperes. And this right here, which you haven't seen yet, this is a magnetic field sensor, and I kind of wanted to show this to you. I hope that I can bring it closer to the screen. Okay, so if you look at this magnetic field sensor, there's one side that has a dot on it and the other side doesn't. And so I'm going to go ahead and align it so that this dot, this white dot, is pointing along the axis of this way. So let me go ahead and stick this back up like this. And what I'm doing is maybe hard to see. I'm actually sticking this.
Oh my
Kind of sticking this so that it's kind of right in the middle.
Oh.
My Slinky.
There we go, boys.
So I'm going to go ahead and show you then. Thought I had Logger Pro up. Ah, here we go. So it's kind of hard. Can you guys see this number up here? I'm just kind of curious.
Yeah.
Yeah, you can? Okay. So right now I'm going to go ahead and zero it. And you see it's in millitesla. It's not quite zero, but it's pretty close. But I'm going to go ahead and have the current flowing, and you can see that number change. So can you see it change? Yep.
Yeah.
Now, I want you to watch that number as I rotate this around. So I turned it off for a second. Have to release this a little bit. So now I'm going to kind of rotate this around. So now it's pointing 90 degrees to the axis. And now it's pointing the exact opposite way. So can you see that number changing? Now I'm going to go back to the original direction. That's the original direction of it. Okay? There's something else I want to do with this magnetic field sensor. I think I actually want to go back to this whiteboard we made. Can you see the magnetic field is very intense, kind of right in the center of this, because there's lots of field lines there. But outside of it, those field lines, of course, they have to form a complete loop, but they're really far out here. And I kind of want to show you that that's true. So let me go back to this. So what I'm going to do is I'm going to start off where it's inside the coil, and you'll be able to see the number up here. Okay, let me re-zero it first. One of the problems with, in a way, it's kind of good I had to do this lab, because if I remember right, last year the students really had a problem with this lab, and that is they didn't re-zero it. Every time you take data, you have to re-zero every data point. And the reason is that, kind of like, remember how I showed you that you can remagnetize a magnet when it gets messed up? Every time I have current go through this coil, since it's made of a ferrous material, iron, it will actually have residual magnetism afterwards. And if you don't zero it again, it's going to be all messed up data. Okay, so anyway, let me re-zero this. Okay, and then I'm going to go ahead and do this again. Again, I'm going to start off with it inside the coil. Okay, so this is inside the coil. So look at the number up in the corner. Okay, can you see the number, I hope? Yes. Okay, now I'm going to pull it outside the coil. What did that number go to, basically?
0.
Yeah, can you see that it goes to 0 outside? Okay. That's what I wanted to show you. I wanted to show you that our picture was, in fact, correct, that it has a very intense magnetic field inside, but outside pretty much 0. Okay. So let me come back to this. All right, so let me explain how we're going to do this lab. So the purpose of this, I probably should show you. Hold on a second here. We're going to be whiteboarding this lab then on Monday. And the lab is kind of in here. So here's the purpose. I'm not going to write it down. I'll let you guys write it down. But the purpose is, you said that there were three effects that might affect the magnetic field. You said, hey, we could change the current. Maybe that would change it. So that's one thing. So it's to graphically and mathematically model the relationship between the magnetic field of a slinky and the current that goes through it. The other thing that you said that might affect it is how many loops there are. So to graphically and mathematically model a relationship between the magnetic field and how many loops. And the last thing we said, well, actually, there was one more thing you said, Kobe. You said something about the radius. I can't change that, but that's a good idea. I like that. I just don't have different slinkies with different radii. That's a good idea. That'd be cool. But the last thing we said was also the spacing of the loops. So that's what I did. And so let me take you through the experiment of how I did it. Was the very first part was I counted out how many loops I had here, and I figured out the distance, and I just changed the current. So that was the first one. The next one that I did was I changed the length of this. And so I kept it at the same number of loops, and I brought this in, and I just simply changed the length of this, always trying to keep this right in the middle. So I had the exact same number of loops. And then the last one was, I don't know if you can see it, but I have tape on this. And so I attached this wire here so that it was only flowing through this part, and then here, this part, and then so on. But I had to keep the length the same, so I had to stretch this out. Okay. Does that make sense? Any questions on any of that? Okay, so I'm planning on just simply sharing the data with you, and then you guys can graph it. You need to understand. Let me go back to the setup. All these are in millitesla, so you're going to have to take all the measurements and convert it into Tesla. So let me show you what the document is I'm sending you. I just got this data. Let me rotate it. Sorry.
Jack, what?
Okay, so up at the top will be the constants. And for instance, this first one, I mean, this is real data. I took it myself. This first one, I found out that once I got up to a current of about 2 amps, all of a sudden the numbers started staying the same for the B field. And that's because I looked at the documentation for the magnetic field sensor, and it has a saturation limit of 0.3 millitesla. So I actually had to get rid of those because they weren't changing. So I dropped those off. And so there's those. When I changed the length, I had one data point that at first I thought was great, but then I tried 1 meter and it was totally different. And I saw the trend didn't make sense, so I went back and I did it again, and I got something totally different. I don't know what was going on with the sensor there. And then for the last one, again, the constants are up here at the top, and I just did different number of coils, and I didn't have any problem with that one. Other than it was kind of hard to keep the current constant because it would, I don't know if it was because it was different amount of length, and so therefore the resistance was changing, and therefore maybe the current was changing. Maybe it was a set voltage. I'm not positive, but I had to adjust the current to get it about constant. So anyway, I'm just planning on sharing that. I'll email that to you. Is that okay?
Yeah.
No problem. Okay. You might also want to, oops, sorry. You might also want to look through your packet about the Slinky lab. It kind of talks about the setup and everything. So just in case there's something you couldn't understand. And right there was kind of telling you what the saturation limit that I should have read probably. Anyway, so I don't really have much more other than I want to go to the calendar. So I'm going to share that link with you pretty soon. So I explained how to do the lab. I'm going to share the data with you. And for our next meeting, which will happen at 1:05 on Monday, I would like to have your whiteboards ready. And I've already made the whiteboard, so if you could just make a copy of them. And there's only 3 in there where you can kind of sketch in what your graphical models are and everything. And excuse me, that would be great. So I don't have anything else though. Oh, have you guys noticed that this on here too? I should point this out. Internet homework is only going to be worth 6 points. So that means you only need to do 6 of them. I would encourage you to do more because the AP test is still planning on happening. The only updates I've heard is that maybe it might actually be happening on the computer. I don't know how they'll do that, but so it's still happening as far as I know. And if I hear something, I'll let you know more about it later. Any questions? Okay, well, that's
Turn
it.
on gravity.
Oh, wait, question?
Yeah, how do you turn on gravity?
Is that Jack? Sorry, Jack, I can't help you with that. I'm sorry about that. Okay, that's it then. I'm going to be sending you an email with the data I would like you to start graphing then. See you later. Bye.
All right.